Today on the Tech Bytes podcast, sponsored by MinIO, we are talking object storage, fast, scaled up, and for private and public clouds, and it's particularly suited for AI use cases. We are joined today by Jonathan Simmons from MinIO to dive into the rather new world to me of high-performance object storage. Let's kick off with a bit of background about what is MinIO, what makes you unique in the world of object storage.
Well, thank you, Greg. Delighted to be here. A little bit about MinIO. It is a drop-in replacement for AWS S3 in terms of an object store, with the notable difference that it runs anywhere. So it runs on the public cloud, it runs on the private cloud, it runs at the edge. And because of that flexibility, it is very, very popular with developers.
So it's not proprietary to AWS. Like S3 is AWS's proprietary storage, and Google's got their version and Azure's got their version. But I could run the same object storage on any of these platforms, the same storage engine, or on-prem in a private cloud, but it also works for Kubernetes and VMware as well.
Yeah, exactly. AKS, GKS, EKS, Tanzu, OpenShift, it will run anywhere. And to that point, we have almost 1 million instances running in AWS itself of MinIO, even though AWS has its own object store.
Okay, so you're not a fresh-faced startup here. You've actually got an existing customer base. You're growing, is I think the message to take away from that.
Yeah, we've got over 350 customers. 77% of the Fortune 100 runs MinIO in some capacity. And again, 1.7 billion Docker pulls at this point tells you that we are the weapon of choice for developers.
So you say Docker pulls. Does that mean you've got an open source, closed source enterprise support model, or are you a product that I buy and use, but the licenses are handled remotely? How does that work if I wanted to trial the product?
MinIO is open source under AGPL v3, which is a purist license, meaning that applications that are built on top of MinIO also should be open sourced under AGPL v3. Some companies don't want to abide by that. They don't want to open source their stuff. And so therefore they choose a commercial license. Other companies choose a commercial license because they want the direct engineer support that it comes with, or they want the enterprise features that comes with the downstream version. But it's a variety of different choices, but ultimately, yes, that's what it is. But you can download it at min.io.
Okay, so people are listening today, they can go and download it and start playing with it and then step up into, if you want to commit the company's vision to it, then you step up to the enterprise support program.
Absolutely. A quick story on that is that, all of our customers to date have come inbound. So they've done exactly that. So whether you're, American Express or whether you're Rakuten, you started out by doing that, by downloading it, becoming comfortable with it, growing with it, and then saying, all right, this is part of my mission critical infrastructure. I need to have a relationship. And so that's how the company was built. Okay.
So object storage is different to file storage. So VMware doesn't have an object storage engine inside of itself today. I'm just trying to draw a parallel here between object store very quickly and file storage or block storage. So most times when you think VMware, you're normally talking to a block storage array of some sort. The object store is where you put objects in and then you just fetch the object and the storage engine takes care of it. But you're doing more than just the object store. You're also doing replication, encryption, identity and access control to the data so you can have the data in stores. How did this product grow over time? How did you get this product out there? Did you start off as an open source project and launch? If I'm starting to come into this product, what are the best features that I would be looking for?
The founders of this company had actually founded a company called Gluster prior to this. And so Gluster was sold to Red Hat, and Gluster still is one of the most beloved distributed file systems on the planet. But they realized that file systems and SAN and POSIX in particular as a protocol wasn't going to make it into the cloud native world, and the world was going cloud native. And so they pivoted. They left Red Hat. They started MinIO, and MinIO has only done object storage, right? So we are entirely focused on that class of problem. And that class of problem is, ideally suited for the cloud operating model and for AI and ML.
Object storage is just like if you're building a cloud, you don't want to have to attach to a fiber channel block, and sudo up a disk and all that sort of stuff. You just want to pull the object that you want and say, go and get me this video, go and get me this image, go and get me this blob of text, and do that. And the challenge there is that has to happen, as you say, via the S3 API, which is, of course, a standard for this sort of object storage, but has to be fast. But underneath it, there's a whole bunch of stuff that like the data has to be replicated in multiple forms. It has to be safe, right?
Yeah. And so you asked earlier about what the model was. Obviously S3 is the OG of object storage.
Mm.
They designed an incredible product, and we looked to that for inspiration. And so in order to be fully S3 compatible, you have to look at that model for IAM. You have to look at that model for ILM and different components. And so, we built a fully featured enterprise object store, including replication, object blocking, things like bit rot protection, erasure coding. All of that got built in very early on and then polished and made just even more enterprise grade over time, which is where we are today.
One of the things that you're pitching now is the fact that MinIO is AI ready, or ready to be included in the AI infrastructure. And AI is unique in the sense that it's got to be this as fast as possible, if not faster than possible. Does that make sense?
Yeah.
And so for you to claim that you've got an object storage which is AI ready, you must be one of the first or the earliest companies in that space. How does MinIO do that?
So I think the class of problem that you're dealing with when you're talking about AI, which is like this apex use case across all the potential use cases that you could use object storage for, is not just performance. So performance measured in throughput, sometimes IOPS, but object storage is generally throughput. But the problem that you have to deal with AI is performance at scale. So it's easy to be fast at 100 terabytes. It's an entirely different class of problem to be fast at 100 petabytes. And so the ability to deliver throughput at that scale is what defines success in AI. That coupled with the fact that if you are cloud native, you are probably the foundational piece of a lot of these things. And if you go back and look at, what's getting built in the AI space, a lot of it is built off of things that are including MinIO. So MLRun, MLOps, Kubeflow, vector databases like Milvus, they're all built on top of MinIO as well. So we're deeply embedded into the ecosystem in addition to being able to deliver that throughput that we talked about.
So I want to ask a question here because you pointed out that you're a petabyte class storage system. Is that correct?
Well, we actually have a number of exabyte class customers, but
okay. Now
that's not for everybody.
Yeah, because most enterprises think of their SANs at 500 terabytes or maybe sub-petabyte class, and that is usually the performance limit the traditional storage array can get to. To be able to store exabyte classes of data, that must just mean you've got the ability to scale out horizontally. Now, you talk a lot about horizontal play object storage. What is horizontal play? Because that sounds like a technology that's underneath here.
Well, object storage as a general class of storage versus file and block can be used for a variety of different things. And what we've seen in recent years is that more and more of those applications have decided that in this kind of next level of disaggregation, I want to focus on being a high-speed query processing engine in the database world, or I want to be focused on, this AI compute layer. And they have outsourced the storage component to the best available storage product for themselves. And that's going to be high performance object storage. And so because of that, you can support advanced analytics, you can support log analytics for threat hunting, you can support AI and ML, you can support databases, you can support Artifactory, and of course you can support the traditional archival stuff. But we are focused on those much more dynamic workloads because there's so much more interesting stuff going on there. And the value proposition for a high-speed object store is much higher.
There's a fundamental shift here because AI does need hundreds of petabytes of data or exabytes of data to be able to process because it has to feed it all in and then try and find relationships between all of it. So one of the first things about AI storage infrastructure is it must scale out to huge sizes, but then it also has to be fast. And the trick about AI storage is that caching doesn't work because you're not necessarily to be able to predict what the next byte is going to be very difficult. Or am I wrong?
Well, there's ways to use caching to improve performance. For example, we just introduced a feature in our enterprise object store that allows you to basically create an in-memory object store, a read-through cache out of all the servers that you have. So when I mention customers that we have that are at the exabyte level or above, they might have 290, 390 servers. If they pool those together, and MinIO is famously very light on memory usage, but if you pool that together, all of a sudden you can create this very large in-memory object store. They have a terabyte of memory on them.
I was going to say,
that you can use as an in-memory object store. And so the fast gets faster in that situation.
So the really interesting thing about this is you can put MinIO, Azure, AWS, but you can also bring it on-prem. It means it just runs on standard x86 hardware.
Yeah.
Do I need any special blessed hardware? Like vSAN, for example, is sort of very proprietary and only works on certain blessed and approved hardware that comes from vendors. I mean, and they say that, well, we can't trust vSAN to run on just any computer. It has to run on this computer. How do you address that?
So MinIO is fairly famous in this regard. You will find MinIO running on a Raspberry Pi. You'll be running on basically Power 9 chips in architectures that include NVIDIA GPUs. So across the entire spectrum. But yes, the answer is commodity off the shelf hardware from Supermicro, from Dell, from HP. Those are the boxes that we recommend. Now, if your use case demands performance, we are going to recommend, single core chips from Intel or AMD. We're going to recommend NVMe drives. We're going to recommend a minimum of 100 gig network, but still that's commodity off the shelf, hardware at this point. That's not unobtainium, right?
No, you're not in the dark arts here trying to conjure up,
exactly.
As you say, unobtainium. It's off the shelf, but you're also if you're optimizing for performance, then you need to spend on performance. You don't race a Lada on a racetrack because it just doesn't have it, right? But if all you're doing is going from the shop and back on Saturday with grandma, it's a perfect format, right? And that's kind of what I'm looking for.
Yeah, exactly. And it's really interesting because a lot of our clients have come to their own conclusion here that NVMe is the right way to go at this point, because they've looked at the total cost of ownership of those drives. They've looked at the performance improvements. And so, yes, it might be 3x, but it's 40x more performant, and its failure rate is 1/3 of what the HDD might be. And so just the economics pencil out very, very quickly. And so they're all moving to HDD sort of en masse at this point, particularly for the workloads that they run on MinIO. Now, some of the other legacy providers might still be doing HDD for archival stuff, but for the workloads that we're primarily doing, the AI and so forth, those are the types of things that we see a lot of this NVMe going into.
There's a vision here that this is a data lake. If I'm an enterprise and I've got hundreds and hundreds of exabytes, and I'm now starting to think about petabyte scaling in my infrastructure, this is somewhere I could go to MinIO and start deploying this in my on-prem data center and start using it for that, because you've got all the features here. You've got the life cycle, you've got the versioning, you've got key management, encryption, replication, and the whole thing. I don't necessarily have to go and buy this branded type of server with this weird custom hardware inside it. I can now start using this.
I think, there's a couple of things that we talk about when we talk about the appliance model. Is one is it's very hard to containerize an appliance, and it's very, from an orchestration perspective, containerization perspective, it just doesn't work, right? And so it's really never going to be a cloud native solution. And cloud native is the model that people are replicating when they move on-prem, right? The cloud operating model, containerization, orchestration, RESTful APIs, microservices, that has migrated to the on-prem data center in a way that is exactly the same. And so the lines between public cloud and private cloud are effectively blurred if you choose the right solution. So that's a huge part of it. The other thing is that this sort of modern data lake, it's like 1/2 data warehouse, it's 1/2 traditional data lake, and it's 100% object store. That coupled with open table formats from Apache Iceberg or Hoodie or Delta Lake, now all of a sudden you can do anything that you want to at a scale that was almost unimaginable just 3 years ago.
Yeah. You've got to break away from the legacy ideas of storage, even the object storage from the traditional vendors isn't in the same class as this. And I want to just, as we're getting towards the end here, one of the statements you gave me here is how are you're making the claim that your object storage capabilities are changing the landscape of AI. And there's some interesting things in there. So I just want to ask you to sort of explain why you believe your object storage is changing the landscape of AI.
So I think if you go back and you look at sort of the core use cases that people talk about when they talk about AI, that hasn't changed that much. It's predictive analytics, it's process automation, there's fraud and security, NLP, healthcare, life sciences, supply chain, those kinds of things. What has changed is the scale of those use cases. And so the capacity to deliver at scale. I'll give you an example. We have actually multiple customers in this area of autonomous driving. They're taking the video off of every single vehicle and they're training that from an AI perspective. When you do that, you are your whole self-driving initiative is based off of all drivers as opposed to writing rules and seeing
Yeah.
how they actually drive, that is exabytes of data. And so that class of problem is entirely different than anything that anybody's dealt with before. And so what we're enabling is them to solve these problems at a scale that heretofore was not in scope.
You just couldn't keep exabytes of data around before. This is kind of a new thing, right?
Much less operate on that data.
Yeah, that's right. And then be able to actually read it in a real time, because you've got to just reading an exabyte of data in any meaningful form. Like, you're not going to read the entire exabyte in less than a few months, right? No matter how hard you try, how much of a compute front end you have. But the concept is that you can access, or you can put up, processing threads on that data and start to consume it, because your storage is big enough, scale out, right? But it also has to be fast. And there's a whole bunch of stuff going on inside of MinIO that makes it just responsive and performant at AI processing speeds.
Yeah, we talk about the GPU starving problem here a lot. You can't starve your GPUs. They're the most valuable assets that you have in your portfolio at this point. And so it's a capacity utilization problem. And so you need massive throughput to be able to feed those GPUs in order to get the maximum amount out of that investment that you can possibly get. You can't do that with other technologies. It has to be an object store that has the throughput capacity to deliver against that. And that means you got to be able to have it and perform it and serve it.
Yeah, you don't want your GPUs 10% idle, because they just cost so much, and they cost so much power that 10% of idle usually adds up to a huge amount of cost. And you want to, and also the second part about AI is, if your GPUs are idle, it can add to your job time exponentially.
Yes.
So you might have kicked off a model generation that's going to take 3 months, but if you're running at 10% idle, it could take 5 or 6 months before it completes. And so you've got every incentive in the world to get these products right.
Yeah, exactly.
So unfortunately, we're running out of time today, and thanks very much to MinIO for sponsoring us today and talking about their scale-out object storage exabyte class. Honestly, the days when I first started with a 5 megabyte hard drive, and now I'm talking about exabyte class storage, it still boggles my mind just how far we've come in a short period of time. Jonathan, if people want to get more information, where can they go?
Yeah, certainly. So min.io is our website. And from there, you can find our blog. We publish 2 to 3 times a week. And it's very, very deep content, deep technical content. You can also join our Slack channel. So we've got 45,000 members of our general Slack channel. It's an incredibly supportive community. So you can learn more about MinIO there as well.
Yep. And you can also get a hold of the product if you want to do a bit of a desktop review, as they say these days. You can get a hold of the product on GitHub, and the links there are on the website as well. Maybe you want to have a bit of a poke at it and see if it's the right sort of thing for you. Well, as always, thanks very much to our sponsor. Thanks to MinIO for joining us today. You can find this and many more fine free technical podcasts along with our community blog at packetpushers.net. We'll have some links in the show notes. If you want to go over there and check out the post that goes along with this podcast, you'll be able to get more information there. Don't forget to follow us on the Twitter at @packetpushers. Hear us on Spotify or your favorite podcatcher.
So, Greg, I just want to thank you on behalf of the entire technical community. I mean, it's been a remarkable run, and we are just delighted to have had the opportunity to engage with you, but more importantly, to listen to you over the years.
Thank you. That's very generous of you. And as always, remember that last but never ever least, that too much technology would never be enough.